That guys, I forgot to do C, which is to graph the stupid thing. Sorry about that. I apologize. So, because we know this, we also... Oops, sorry. I didn't mean to do that either. Because we know this right here, we know the x-intercepts. We have an x-intercept at 1. That's because that's x minus 1. We have an x-intercept at negative 1. Because that's what makes this 0. So, if I plug in a 1, it'll make this 0. If I plug in negative 1, it makes that 0. If I plug in a 2... makes both of those zeros, which means this thing's going to bounce at 2, because there's 2 of them right at 2. Look at your end behavior. Your end behavior, this is an even degree positive, so they're both going up. We just said it bounced and come through and then comes back through. We can check the y-intercept by plugging in 0, and the y-intercept is 0, negative 4, so I guess it has to come clear down to here. So this thing should look more kind of like this-ish. Yeah, something like that. Okay, bounces right there at 2 because there's 2 of them. Hopefully you remember that. Okay, let's go ahead and take a look at number 4. Number 4 says solve the equation. Okay, to be able to solve this log equation, if I have 2 logs, I have to get them together first. So notice they are both log base 6. So I can actually combine these down into one log base 6, and remember, addition is multiplication. So that's x plus 4 times x minus 1. That equals 1. We can now eliminate this log right here by using this as the base to that exponent. So 6 to the 1, so that goes away. I distribute in, giving me x squared minus x plus 4x minus 4 equals 6. We then get x squared plus 3x minus 4 equals 6. Subtract the 6 over. That gives us x squared plus 3x minus 10 equals 0. Look to hippo butt, hippo butt, hippo butt. X squared is what? Times what? Factors of negative 10, add to 3, plus 5, negative 2 equals 0. That means x equals negative 5 and x equals 2. The only thing you have to be careful of is you cannot take the log of a negative number. So when I plug negative 5 in, right here, I get negative 5 plus 4, which is negative 1. So negative 5 is out. If I plug in a 2 here, I get 2 plus 4 is 6. That's fine. If I plug in a 2 here, I get 2 minus 1, which is 1. That's fine. So x equals 2 is our only solution. X equals 2. Okay, the following function is 1-to-1. Write the equation of the inverse. So here we go. Inverse is not so bad. Remember, inverse means inputs become outputs, outputs become inputs. So a lot of times we'll first go ahead and write this as y equals 1 over x plus 2. Then we'll switch inputs and outputs. So in other words, we switch x and y. And now we just go to solve for y. So I would subtract 2. That gives me 1 over y equals x minus 2. I'd multiply by y. And I'd get 1 equals, I would write it like this, x minus 2 times y. I'm solving for y, so I divide by x minus 2. And I get y equals 1 over x minus 2. So we write it inverse notation. We write f inverse of x equals 1 over x minus 2. And you're done. Not so bad, eh? Okay, let's see if we can do one more. Let's see if we can get 6 and 7 done before we go. Okay, graph the solutions. Actually, you know what? I'm going to stop it here. Nope, we're good. We're going to stop. I'll do this on another video. See you soon.